Welcome back. This is the day the Lord's made. Unless you rejoice me glad in it. In this video, I want to just expand upon electromagnets and how we actually make electricity by just spinning magnets. So again, this is how we generate most of our electricity here in America and worldwide for our outlets. So and the general idea is if you have a magnet, it produces a field. And so we have these field lines, this magnetic field that's produced by a single bar magnet. And if you put a compass in different places, it points where it wants to go. It just points with the field line. So it turns out that electrons would be influenced by these fields, all right? So if there's a field that's present, electrons are influenced by it. If you just keep a magnet stationary though, the electrons that are inside of a wire don't move because they find the place where they're supposed to be and then they stay there. But if you move the magnet, that results in electrons experiencing a force because they want to adjust themselves with the new field that's been produced. So again, if the magnet stays put, no electricity, but if the magnet moves, the electrons want to move in response to the field moving. All right, and so we can change how much electricity we generate, how much voltage we produce by how many coils we have. So if we have more coils, more loops, it can increase the amount of strength of the field that the electrons produce as they move, because not only does the bar magnet have a field, but as the electrons move, they produce their own field too. And so the general idea is if the magnet moves, we can produce electricity without even being connected. So again, in our typical circuit, we think about like the whole path being connected and that the electrons have to have a place to move through the entire path. And so if we have a disconnected circuit somewhere, then we lose all of it. But with electromagnets, it's not the same, because as long as the magnets move, it's producing electricity in something it's not even touching. So again, the general idea is if we have alternating current, we can produce electromagnets, but in a DC one, we can't. Because if we have a DC circuit, meaning like direct current, like a battery, the battery just produces electrons going one way. So because it goes both directions. So if the electrons move, they produce a field. And if they produce a field always going the same way, then the field is always the same. But if we change which way the electrons are wanting to go by having alternating current, that can result in us producing a shifting field, which then if we have a shifting field, this would also influence a magnet. So in this case here, the moving magnet resulted in electrons moving. In this case here, we already have some electrons that are moving, and they can make if we had a magnet over here, the magnet itself would want to move. And so connecting this to transformers are again just a way that we can change the voltage. We can step up or step down the voltage by the number of loops. Can't do it with the direct one, because if we have direct current, the electrons, they start moving, they produce a field that doesn't change. So the electrons over here aren't going to move because there's no reason to move once they get to the place they need to be. But if we change this so that's alternating current, this results in the electrons over here wanting to wiggle too. So let's go ahead and, if we get this a little bit closer, we'll probably be able to see it. So here we have electricity being generated because as these electrons move, they influence these electrons to move because of the field they generate. Can't click on that. All right, so then how do we actually produce electricity? Almost every single power plant does the same thing. All they do is they spin a magnet. They're going to spin a magnet, and that's going to result in electricity being generated in some wires that have been wrapped around. So this would be an example of how like your typical hydroelectric dam works. So all they do is they just, the water falls down, it spins a magnet, and as the magnet spins, it causes the field to change. And so if we show the field, we'll see that the field, the compass, is constantly changing as this magnet spins. So as the magnet spins, that field permeates over to these coils we have here, and these coils then adjust where they're going because as the field changes, they want to move too. And so in America, we've adopted 60 hertz, which means we make these things here, the magnet spin at 60 hertz. And then that results in these electrons alternating back and forth. And so transformers just basically take the voltage and step it up or step it down, but ultimately every single power plant does the same thing. If it's a wind turbine, all it is it just the wind spins a magnet. For a hydroelectric dam, it just, the water falling spins a magnet. For a coal power plant, what we do is we burn coal, and then it gets hot, and we make some water turn into steam. And as the steam moves, as the steam expands, it moves and pushes through. You can think of it like a wheel, and just as it spins through, it spins a magnet. Nuclear power plants work the same way. They just make water hot, the water turns to steam, the steam as it moves spins a magnet. So that's how they all work. All right, Godspeed.